Hello everyone, welcome to Maths IEC. Here's another exam style question for GCSE Physics. Now this question is about specific latent heat, and also it's connected to energy and power efficiency, all that. It's a good exam style question. Pause the video and give it a try. When you want to check the answer, press play. A student uses an electric heater to melt 0.3 kilograms. This is the mass of ice at 0 degrees Celsius. The heater has a power rating of 120 watts. So I know this is the power. And is switched on for 900 seconds. I know this is the time. The specific latent heat of fusion for ice is 3.3 times 10 to the power of 5 joules per kilogram. Calculate the total energy supplied by the heater. Now, this is just a power question, really. So I know power is equal to energy divided by time. If I need to find the total energy, I need to bring T to this side. So energy is power multiplied by time. Now, I know the power is 120 multiplied by time is 900 seconds here. So just multiply these two. So the answer for the first part is 108,000 joules. Calculate the energy required to completely melt the ice. Now this is E equals ml. You can call it mlf or just ml. The mass is 0.3 and L is 3.3 times 10 to the power of 5. So here you get 99,000 joules. Use your answers to A and B to calculate the efficiency of the energy transfer. Now, efficiency is defined as useful output divided by total input. Now, the useful output here is the amount of energy went to ice, which is 99,000, divided by the total input is the amount of energy supplied, which is 108,000. So I get 0.916. So you can call it 0.92 to 2 decimal places. So 0.916 recurring. So let's call it 0.92. Now, the question here is efficiency and not percentage efficiency. Like some people multiply this by 100 and give the percentage efficiency. It's not wrong, but if the question says just efficiency and not percentage efficiency, I'd rather leave it like this. Suggest one reason why not all the energy from the heater is transferred to the ice. Obviously, this ice must be in some sort of a container, say a beaker or something. And so the certain amount of energy will obviously go to the beaker. That's one thing. And also energy will just go to the surroundings while it's being heated. So here's the electric heater and you have some ice here. So you can't really stop energy being absorbed by the beaker, and also some of the energy from the heater will go to the surroundings. Some energy is lost to the surroundings as heat. Also, the beaker absorbs some energy during this process.